Here's our circuit and our breadboard. As we can see, it's connected to the IOs. We're writing from outputs 0, 1, 2, and we're reading inputs 4 through 7. And as you see, the breadboard is connected to plus 5V, VCC, and ground. And here we have our pins. We have our gate diagram with the pin numbers. And here this is telling us what each of the line state writes or reads. So 0, 1, 2, input clock reset. 4 is going to read Q1 bar. 5 is going to read Q0 bar. 6 and 7 are going to read Q0 and Q1. And so the output is going to be not Q0 and Q1. And so here, since Q0 and Q1 are both 0, we're in the state of A. And as the state machine definition says, when input goes high, the state should transition to state B. Boom. 6 is active. And so Q0 is high, and that denotes a state of state B. And when input is high, it should remain there. So as we see, it just doesn't change. Once input goes low, the state should transition to state C. Boom. Q1 is high, that denotes state C. And then, as we see, that no matter what happens, state C should unconditionally transition to state A. Boom, back at state A. And when, from the reset state, state A, if the input is low, then the state should transition to state C. Back at state C. And as we see, unconditionally, so if we put the input high, it's still going to transition to A, the reset state. And so we can go back to state C real quick. And as we said before, 5 is Q0 bar and 4 is Q1 bar. So as we said, the output is defined as not Q0 and Q1. So 6 is Q0, so not low and high. We see that result would be active. And same here, if we did, since 5 is Q0 bar and not Q1 bar, so this would be active, so that would result in active. So we see that checks out. And boom, the output is active in state C and not active in other states. As we see, the output would not be active. And yeah, that's our state machine. I'm gonna go back to it real quick.